Hello everyone, in the series of learning aerodynamics, in this video lecture let us discuss about drag polar, and let's see how to obtain the drag polar equation based on the expression. So first of all, drag polar, what is meant by drag polar? Drag polar is nothing but it is a relationship between CD, that means drag coefficient, and lift coefficient. So that is we can represent it as the equation. We can represent it, the drag polar as the equation. That is what we say CD equal to CD naught plus KCL square. This is the final outcome of the drag polar, and how we are obtaining this expression we will see. And then this drag polar also can be plotted on the graph. So we can plot it on the graph, and we can that means that can be represented in terms of CD and CL, and then we can say what is okay CD naught and what is KCL square. So that is what we are seeing here. So CD naught is nothing but this component, that means that zero lift the component, drag due to zero lift, and this component is nothing but drag due to lift. That is what we say, we can just say as the combination of that component that is due to lift. So this K, how we are obtaining this K, that is a combination of all the drag, that is nothing but we can say parasite drag, wave drag, and induced drag. So those component everything is included, and then finally we are getting this K, that means KCL square. So this is a final equation or final outcome of the this drag polar. So we will see how we are obtaining this. So first of all, let's see about drag. Total drag, we all know that it is the combination of parasite drag, wave drag, and induced drag. So this parasite drag also has the further classification, that also we know, that is nothing but form drag, interference drag, and then skin friction drag. So that combination of all only we say as the parasite drag. Then wave drag, we all know that occurs at the supersonic condition, and then induced drag, we know that is the drag due to lift. So first let us discuss about the parasite drag. Parasite drag, we say as the that means we can express that is equal to the zero lift drag or lift drag due to zero lift, incremental parasite drag due to the change in lift. So that is what this parasite drag, whole component of the parasite drag, we can subdivide it into two component. This zero lift drag or drag due to zero lift, so we can just represent it as the CDP naught, and this incremental parasite drag we are representing with the delta CDP. How this delta CDP we are obtaining, that we will see. Generally what happened, this curve represents the change in drag. So small change in drag leads to or varies squaring of the CL. That is what we have to understand. This because it is a graph between CL and CD. So small change in this delta CD varies as the squaring of the CL. So that is what we say, and approximately equal to CL square. So delta CDP, that is a change in parasite drag due to lift. So that is proportional to the CL square. If you are equating, then we are putting one constant, that is what we say K1 CL square. So delta CDP, that means a change in our incremental in parasite drag due to lift, that is equal to K1 CL square. Here K1 we are taking it as the proportionality constant. Then that is how we are obtaining parasite drag. So parasite drag now it is equal to CDP, that means zero lift drag plus K1 CL square. So that is we are obtaining. And then second component is nothing but wave drag, and how the wave drag we are obtaining, that is nothing but generally we know wave drag is caused due to the formation of shock waves. So that shock waves around the aircraft, So around the aircraft, okay, shock waves forms. Because of that, wave drag occurs. Generally, it happens in the supersonic flight condition, because generally shock waves occurs or shock waves forms, okay, in the supersonic flight condition, that we all know. And then this coefficient of wave drag, how we are expressing in the similar fashion, how we have expressed the parasite drag, in the similar fashion we are representing parasite, that means coefficient of wave drag equal to coefficient of wave drag at the zero lift and plus incremental in wave drag due to change in lift. So that is what we say, because this coefficient of wave drag we say CDW, so that is the notation we just say. Then coefficient of wave drag at zero lift, nothing but CDW0. Then incremental in wave drag due to change in lift, so that we are saying as the delta CDW. So then further we are expanding this term, the CDW0 is as it is, that means coefficient of wave drag at zero lift, okay, plus then this incremental in wave drag due to change in lift, that we are representing this one, because we all know that this is the wave drag is the component of the pressure drag. That also we have to understand. Wave drag is the component of the pressure drag, that is caused due to the compressibility effects. So by taking the compressibility effect into account, that is what we are getting here. 4 alpha squared divided by square root of m, okay, that is Mach number, okay, free stream Mach number, m square minus 1. So m infinity nothing but free stream Mach number. So finally we are getting coefficient of wave drag is nothing but it is equal to the coefficient of wave drag at zero lift, that is nothing but CD W0 plus incremental in wave drag due to change in lift, that is nothing but 4 alpha square divided by square root of this m, okay, and that means free stream Mach number square minus 1. Then further we are expanding this term, that alpha is further can be expanded, that we are expanding this 4 by this we are keeping as it is. Alpha is expressed as the CL into square root of m, okay, m infinity square minus 1, that is nothing but this is a free stream Mach number square minus 1 whole divided by 4. So because it is in the square, so whole square we are taking, and then further simplifying we are getting this equation CDW equal to, so we just say that CDW equal to this one. So CDW equal to CDW CDW0 plus CL square into square root of m, okay, infinity square minus 1 by 4. So this is the final expression for the wave drag. So wave drag we are getting like this. Then this one further is okay simplified into this component, that means wave drag, okay, coefficient of wave drag at zero lift. So plus this okay, except CL, other things we are taking as the one constant, so there is K2. So CDW0 plus K2 CL square. That is how, okay, we are obtaining the wave drag. So wave drag, okay, component we are getting this final expression for the wave drag is nothing but this one. It means we can see as the this. So this is equal to this. So CD W equal to CD no, okay, CD W0 plus K2 CL square. And then we have one more component, nothing but induced drag. So we all know that induced drag, okay, generated or created due to the lift. So whenever there is a lift, okay, because generally wing produces the lift, so because of the lift, okay, the drag arises. That is what we say induced drag. So nothing but a drag due to lift. Induced drag is nothing but a drag due to lift. That component is given by CL square by pi AR. So this is given by frontal lifting theory, as we all know. So this component further we are expressing. So this component, okay, further we have expressed CDI equal to, okay, K3 into CL square. So induced drag becomes K3 into CL square. Then now we are just putting in the equation total drag equal to what? Total drag equal to parasite drag plus wave drag plus induced drag. So we are substituting all the component of the parasite drag. Parasite drag, okay, we just CDP plus CD, okay, this one. Parasite drag plus wave drag plus drag, okay, induced drag. So this component is further expanded here, because CdP we know CdP naught plus K1 CL square, that is what here we obtain CdP P naught as it is, okay, zero lift drag at okay, that means drag at zero lift condition. Then this component we have obtained delta CdP equal to K1 CL square, plus this is for the wave drag, okay, this is for the parasite drag, and this is for the wave drag CD W naught plus K2 CL square, plus this is nothing but induced drag K3 CL square. Then this is further we are, okay, putting in this one, that means we are taking this component, that means obtaining the coefficient of drag at a zero lift condition for the parasite and wave drag, that we are putting it together here. And then we have a, in all the KCL square we have a K1 K2 and K3, K1 K2 K3, then that is, okay, multiplying with the CL square. So this component further, okay, we have put it, okay, CD, this one we can say as the CD naught, plus this further, okay, K1 plus K2 plus K3, that we are taking as the symbol K into KCL square. So this is how, okay, we have obtained, or we are obtaining the CD equal to CD naught plus KCL square. I hope this lecture clarifies how we are obtaining the drag polarity equation, and also how we are representing in the graph. So because it is nothing but it is the drag polar plot, okay, between the vertical axis CL and horizontal axis CD. So in this, okay, we generally, this component is nothing but parasite drag component, or we can say zero lift component, zero lift drag component. Then rest all this component, okay, from starting from here it varies as the square root of the square of the lift. So that is what further, okay, this is the final equation, okay, this curve only represents the final equation, that is CD equal to CD naught plus KCL square. So this is how we are obtaining the in the theoretical or analytical way, and that is what we are representing in the graphical method. I hope, okay, this lecture clarifies, or this video lecture clarifies the drag polar equation and how we are obtaining it on the